Excellent.
I noticed Mr. Keshe is in tonight. He missed all the good stuff at the beginning. Yeah, Tony, try not to use glass. Glass and caustic don't get along too well.
I've been listening for nearly 20 minutes.
Okay.
I've been sitting in the background listening to all your expertise. There's a couple of things regarding caustic. You know, when you mentioned that you went to buy it and they said you need a license or whatever, in production in the factories, when we are asked to isolate them and put them in a specific area in the factories, they have a cage for it now, or we put it in plastic containers, big containers, we seal it. But when you use the caustic, never throw the cold. Most of you don't do cold caustic after the use. What we do, especially in production, is we found out that if, for example, we put copper plates in a cold caustic, before we put in the hot caustic, we produce a better nanomaterials. So a day or a few hours before they put the plates into the hot caustic, they leave it into cold caustic from previous processes. It takes all the resin or whatever is on it off and somehow prepares everything for the next step. But on the other hand, when you use hot caustic, I've seen, we had Richard in a factory in Africa, and I realized he goes directly to steam the first time, and you find out it's a total failure when you come to production of gases or nanomaterials. You have to, the way the process is done is that instant first heat submergence, which brings the nanolayer out the way it should be. And you find out if you steam coat or rely on the steam coating, which a lot of people do it the first time. Even when you make what you call the coils, you'll see failures. The failure comes a lot from what do you call it, the gas torching. We see failures. We see failures with steam coating, first layer steam coating. You can't steam coat.
Yeah, we've been fielding.
Pardon?
We've been fielding a lot of people having questions with their nano coating and having it fail. Sections of their coils simply do not coat. What we're suggesting right now that seems to work really, really good is you give it a bath in vinegar and salt for about 15, 20 minutes, rinse it, and immediately put it into your caustic caustic solution. You can go directly.
If you look, you answer it back again. You say salt and vinegar. It's again the sodium.
Mm-hmm.
It's that sodium which creates the environment for the nanomaterial of the copper. Now I'm back in the laboratory work more and more with Nano in the research center. I've been off this one nearly 2 years, 3 years. I see a lot of things because I have to literally be there with all these 20 or 30 people working in the factory. They're all scientists, but they have no clue about nanomaterials. And one of the reasons I see it failing, I explained that to Richard when he was there, that they just, once it's nano-coated, it's nano-coated. Once it's nano-coated, till literally you put it in use, it should not be touched. A lot of people have a failure in coils is because they push the coil through the second coil, and in that pushing, they destroy the nanolayers, they create dams. It's not that they didn't make the nano coating correct. It's the way they pass through the coils. They push it. It doesn't go through. So when you push it, you crush the whole thing. The other thing with a lot of people who do the gas coating, even with the coils, you got to teach is that you have to consider which coil is what and what it does. People just, what do you call it, put gas material on the coils and that's it. If you put nano-coated coils, you don't see any behavior. If you put GANs coated, you see a different behavior. A lot of people don't know, and I have been away from teaching these things because I thought a lot of people understood, is you GANs coat like the, what do you call it, your magnetical, always with CH3. You nano coat your gravitational, always like with CO2 or zinc oxide. And you cannot just nano coat both and GANs coat both at the same time in the same way. These are now back in the, what do you call it, in the laboratories. I'm getting involved more or less on a daily basis with research. I see the things which has been missed in teaching, or people never understood. And these are failures. We are testing even today the new generator. We've seen the failures, and when I look at the failures, it's a small twitches which has not been done properly. The generator can generate indefinitely, but when it comes to certain things, it has not been done in the production the correct way if it's a failure. This is why some of the maggraph system work perfect and some they don't do. They come off the same production line. You never touch nano coated material and after GANs under no circumstance. It doesn't matter it's a plate or it's a tube or whatever. I walked in the factory and I saw Richard has put all the nano coated plates flat on the table. I said, Richard, this is impossible. You destroyed whatever you made. It's one-sided. Only one side which is not on the table is not damaged, and then you don't see performance. And now that the plates have gone into production, we see failures. When I was in the factory in Italy, I saw they're piling nano coating and piling the coils like a, what do you call it, like a fish on top of each other, like 200-300 of them. I said, do you understand, you lot, what you're doing? And then when I looked, most of the failures or recoating came because of the handling. People don't understand nanomaterial is different. When you showed your caustic bottle that you bought, read what does it say. Some of the caustics have potassium mixture in it. That little bit, 2%, 3% potassium makes a huge difference in the production of nanomaterial in the current flow, because the spacing is different when you use potassium. And these are all missed in the process of everybody's making nanomaterial, GANs material. And I see people say, oh, it doesn't work. And when you look at it, you know, when you make the coils, how do you bond the coils? You just put the coil inside the coil. What about if you wrap the coil inside with what do you call a GANs coated tissue with aluminum? It becomes a capacitor coil amplifier. Yes. People don't like to do it because in putting it through, it gets crushed or whatever. If you make it small enough that it can go smoothly through, somewhere that coil will touch and create that amplification and capacitance. The little, what do you call it, ignored procedures is creating a lot of failures or successes. You were talking about putting your foot in front of the fire. Get yourself a nano-coated material, copper, and hang it behind you where you're sitting. Or hang a couple of nano sheet copper plates around the fire. See how you feel in the heat temperature. Or hang a couple of GANs bottles of CO2 behind you where the fire is. You'll find out more or less, if you get it right, your back is as warm as the front.
Yeah, this is what I've noticed with the 2 small plates that I've just put up in my window, is I don't feel the cold coming from the window anymore.
Yeah, but the thing is not coming in. The heat source reflects back internally.
Mm-hmm.
This makes a connection with the whole process. If you take the grill off the front of the fire and nano coat it and put it back on, see how it feels. In what do you call, we are now testing with construction materials. Do we need these rigs sitting there with jumpers and a hat? Yeah. What about if you put few plates with nano coated gas on the floor on the top? It should be at 24 degrees. I know 24 degrees is not warm enough, but in where we are, every day is 40, 42, 45 degrees. 24 is comfortable. So the countries in Africa don't have access to huge power supplies. And air conditioning is privilege. So we are looking into creating house environment where 24 is comfortable. Nanomaterial creates, if you put zinc, copper, and iron nano coated, you'll get around about 37 degrees. Test it. This is how your blood works. So you have to go, for example, how do we feel cold? Why do we have hypothermia? When we have hypothermia, what material changes which creates that hypothermia? Is it reduction in iron? Or is it reduction in zinc? So if you take one out of the elements, you reach the temperature you want. Now in Africa, we are deeply looking into construction. We have to. That saves building 100, 200 power stations across Africa, maybe more.
Oh, wow.
Yeah, now we are a research center. We are a governmental organization. We have access to things that it was unimaginable 6 weeks ago. We have inside Ghana Atomic, we have huge access to the whole structure of the nation. Now for us, it's just a telephone call. So we start looking options, and we are building the first Keshe Foundation building next month, only using materials which we design. We don't see any need for air conditioning. At the moment in the factories and in the offices, we were there with Benjamin yesterday. You walk in, if the air conditioner is not on, you leave. It's impossible to sit. You just, I was teaching a couple of weeks ago. The water was dripping from my tie.
Well, you should take your suit coat off once in a while, Mr. Keshe.
Oh, it's not a suit coat. Everybody is the same.
Yeah.
People just take a shower. It is, you cannot move. It's impossibilities. So we are looking in, you're talking about the animals and the other things. We're looking how you can change the condition. Caroline is heavily involved in animal care at the moment. And we see they literally bring dogs dead on the table they used to die from heat exhaustion. Yesterday I was in the veterinary with Caroline. It's a huge dog, must weigh about 100, 150 kilos. And he came in with a heat exhaustion. And they usually die. And I've taught Caroline how to use the materials. They just wash them with CO2 gas. And they go into convulsion after the heat exhaustion. We just rub them and give them a few drops of 2, 3 different type of, gas, and they just walk off. we see new application, and now we are going to emphasize on it to bring it out, because I'm back in research again. The manufacturing and management of the manufacturing has been passed on to Keshe Foundation to a team, it's been given to a new management team that you will see. So it gives me a lot of time for development, and now we start teaching in experimental level the way we used to do in the Sasana 2 years ago. But it's encouraging to develop, but understanding the basic is missing. And it came to me when I saw Richard is here to teach the new people, and he's doing it everything wrong. The connection of the wiring when you do to make ganses is done totally wrong. And you think people at the top of the structure, people who've been around, they know it by now. But it's become a wrong habit, and they think it's the right way, and you can send them from one factory to another. It's a failure after failure when it doesn't work, because it hasn't been taught properly, or it hasn't been understood properly. There should be new manuals, and we're asking it to be done now. It's going to get done properly for the factories or whoever wants to produce it. This is why some maggraph systems work and some they don't. Nothing to do with the system work. All the systems works, but at the moment when the guy was putting the system together has made a failure. Now, I was in the test lab 2 days ago. I'm developing a system that you can check where your nano coating has failed, where you failed it, where you crushed it, where you didn't do it properly. Very, very simple things. If you put a, what do you call it, a voltmeter, and just go nudge by nudge, coil by coil, every ring, you will see where your failure is. Before you put it into the box, before you seal the box and say the unit is there, you can see. There should be such a thing. I'm introducing a totally new design coils in the generator. That's why it works this way. A new totally design in maggraph system. If you remember when we did the maggraph teaching the blueprint week, when I explained, everybody went this way, that way, and I just left it. This is my habit. I don't say it has to be, because we don't know what's the outcome of new way of doing it. But when I look back from the first day, the first time we start teaching the maggraph, we were supposed to get in the blueprint, I put it the right way, and everybody got involved, this, that, some work, some don't work. But now we produce with the generator system order of magnitude increase in power. But just looking after a few little details.
So on a practical note, what would be the handling recommendations for the nanomaterials? I understand you say don't handle them.
Don't
we
touch.
We need to handle them. We need to handle them to put them together.
Edges. Everything has an edge. It's like a film. You know when you had a film in your hand?
Okay.
Yeah. You don't put your finger in the middle of the picture, do you?
In the case of a coil, there are no edges.
Yeah, but in case of the coil, for example, there are very little things. At the moment, we have this long piece of wire which goes ahead of the magnetic or gravitational coil. Yeah. You don't need to put it through the long piece. You put it backwards through the back end, where that long piece doesn't go anywhere, so it sticks out on your end. Do you understand? So little things, when you have a long piece, then you have to pull it. But it's creating a position that the thing just floats down. You don't need to push it through. You got to GANS coat all the coils individually. Magnetical with CH3, and everybody puts it in the GANS, all of it. There's no potential difference. Where does it want to transfer? Everybody uses the same GANS for inside and outside. Where is the potential difference?
Oh my Good.
Okay, so our concept of fully assembling the system and then nano coating it to avoid the damage, that's problematic because
You
of the
can
gas.
do it, yeah. It can be for production. We are doing it, but it's useless.
Okay.
These are little things. You see, we at the moment we're going to literally open the first spaceship platform. We are building the first, like Cape Canaveral in Miami. We are building the first one in Africa, but for handling the spaceships. The structure is different. What I'm talking and looking at, the structure is totally different. In a normal system, you look into, you enter the space, what do you call it? The steps to go in or ladders to go in.
Yeah.
The loading of the spaceship, we're looking to enter from underneath.
Do you have a candidate?
Pardon?
Do you have a candidate?
What do you mean?
As in a person who is willing to
the motions who win, they are the motions who we enroll, paid for, they are the people who are the candidate.
I think Alper wants to be the guinea pig.
I would love to, please make me guinea pig.
No, but these are the things we are looking at. It's got to be done. You can't build a whole structure and find out you're going the wrong way.
Yes,
this is on a platform entry. And this platform entry has to be fully nano materials. This again interaction, again accepting to be able to do certain things. All comes back to nano coating and understanding interaction of the fields of the matter level. Just people make coils and just pile them on top of each other. It burns my heart, but it means they haven't understood. How can you teach them? Yesterday is the first time in 2 years, 3 years, I literally with the guys in the factory, I got involved in nano coating. I haven't done it for years. And to me, I was doing it natural. It's the process I understand. And I could see how Richard has taught them. It's all failure after failure. I was telling Benjamin, you got to look. I was talking to the manager of the factory. Look how it's done. And you see the heat it builds up, the heat. You got to understand how you make nanomaterial. It's in the name of it. Gas is in nano state. You have to, in the top layers, first at least 5,000 layers before it goes into the automatic 30, 40,000. You have a matter which is a copper. You have to melt the top layer and in such a rapid way evaporate it. That become a gas of itself, and in that position create such a condition that the structural pull pulls it back to itself, but it holds it. It becomes a gap, imaginary gap. If you made a good nanomaterial, you should see copper, total copper, as long as your plates are in the liquid. The minute you drain the water, you should see a structure of the nanomaterial coming up. If you make a nanomaterial and it gets black while you're looking at it while it's in the liquid, it's not a nanomaterial, correct?
Well, to me, on a practical application, steam shouldn't escape. So I put an extra...
In a practical way, what we do in the factory level is that we make a pipe into the tank.
Oh.
The container is sealed. Yeah?
Yes, I get it.
Yeah? So in practical, nothing escapes because we have a steam and everything. And in a factory, from the time we put the plates into the box and it gets sealed, till it's nano coated and it comes out, You don't touch anything.
No way.
In a practical way, when it comes out of the system, you don't again touch anything. You just touch the edges and you hang it in the containers. There should be no physical touch.
I know, but how do you feel that way? This is an indication why it doesn't comply with anything related to its nano coding. I mean, this is a just way to hang it and keeping it.
Yeah, but this is the way you stay warm, and you put your finger inside the freezer.
Perfect.
The freezer being the nano layers. You don't touch. I was explaining this very recently to the guy. I said, a nano layer is like a body of a woman. Do you touch any woman you see? You put a finger, poke them, or tickle them? No. You have to get permission, and if it's the permission, you have to understand it's a live thing. Once you move nano layers into, especially into GANs, you're dealing with the dynamic, and people just look at it. To me, I see the motion, I see what it is in the GANs material. And to the people who's just doing it, we are releasing a new product. It's going to shock a lot of people in the next few days. And this is by understanding the structure, by understanding how to handle nanomaterials. I'm back into research and space development. You will see a lot of new things. Past 2 years I've been away from. But I had to go through the process of setting up the factories and everything else to be now back into the university and the research. I'm in everywhere, back what I used to do for 10 or 15 years. And you'll see new innovations, new products, totally new line of developments in every aspect, from the health to agriculture to animal to space.